Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by Techstrong and Logs.io. My name is Cody J. Brown. I'm the host of Techstrong Learning. We have an exciting presentation ahead, but first, I have just a couple of housekeeping notes. First, today's session is being recorded, so if you miss any of our discussion or you would like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live webinar today. If you have any questions, we want you to go ahead and submit those using the Q&A tab on the right side of your screen. And that's also where you'll find the chat tab, where you can chat with your fellow audience members or just let us know from where you're tuning in. We will have a couple polls throughout today's presentation, so be mindful as your participation is highly encouraged. And there are some handouts in the handout tab. I believe we've got 3 links waiting for you there to aid in today's webinar. Finally, at the end of our webinar, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. Our topic today is how to simplify Kubernetes monitoring on AWS, and I'm joined today by Spencer Boss, engineer at Logs.io. Spencer, thank you so much for being here with me. I'm going to give you the floor.
Yeah, thanks, Cody. So just like Cody mentioned, my name is Spencer Boss. I'm one of the engineers over here at Logs.io. Today, I'm going to be talking a little bit about how to simplify Kubernetes monitoring on AWS. So I'll just kind of jump right into it. So basically, I've been working with developers for the better part of about 6 years, maybe about 6.5 years. And I've been focusing more specifically on observability in the last 1.5 years or so. And basically, while working with developers, I've been basically saving teams a bunch of time, whether it be through productivity or just enhancement to their actual environments and different things like that, and just better using their data. And just sort of a fun fact, maybe a little bit different about me. I'm a pretty active person, so that's actually a picture with me and my dog at the top of a mountain called Osceola. So it's in New Hampshire. I love hiking, biking, skiing, basically anywhere in the mountains you can find me doing stuff. So cool. So today, what I'm going to be kind of covering as sort of an overview is basically I want to cover what are really the challenges when it comes to monitoring Kubernetes environments, especially when you're talking about AWS environments or just really any of those environments at all. And a lot of the data or the challenges around that and getting that data and actually monitoring those environments is what are we doing with that data? How are we actually collecting it? How do we organize or what are we doing once we actually collect that data? Are we removing data sets, or what are we actually doing to improve our actual monitoring of that data? And then when we actually monitor that data, how do we make sure that we are understanding where the data is going to be used or where's the overlaps? Why do we actually want to make sure that data is actually correlated together? So when it comes to data collection, we're going to be focusing a lot around open source and using open source tools to do this. And because open source has so much more flexibility and different things like that, I'll get into kind of the nitty gritty there. But really, we want to understand what tools work best, or we want to use the right tools for the right environments in the right places. So we're going to talk a little bit about what we suggest and how we would do it, especially with specifically our environments. And then when it comes to data optimization, data usage, or how do we intelligently use the data? Because we understand like data doesn't have all the same values. Not everything is a one-to-one of importance level and different things like that. And kind of going against that old adage of let's just collect everything and let's figure out it later. And then the last piece is centered around kind of data correlation and how we actually unify visualizations and how we unify data together so that we can quickly identify fixed issues as opposed to constantly jumping around and trying to figure out where along the story is the problem. So I think we had a poll question right here, if we want to throw that up. So I'm not sure how long we wait for those poll questions to come up. I think, all right, so I guess we'll move on. So I think you can see the results, or you can see the polls after. But basically, what we wanted to do is talk about, oh, okay, cool. So awesome. So it looks like we have about half of us, or a little about half of us are in the open source world, and about a third of us are in the proprietary, and then nothing at all, and then other. So I assume that means like kind of a combination of all. So if I go, which is pretty cool. And I think we're going to talk a little bit about why that's actually important. So when we talk about open source, and we're talking about why we would actually want to do this, it's centered around a lot around what I think is important is that basically we're not getting this vendor lock-in. So when it comes to tools and different pieces of this, you're not focused really on like what's going to make the company money. You're really focusing on like what features and what things are going to be easily integrated. So as a prime example, with if anyone's familiar with the CNCF, or the Cloud Native Cloud Foundation, there are a lot of tools associated with that foundation, and Kubernetes is a huge part of that. So is Prometheus, as an example. And because of these tools, and they integrate very, very easily with each other, because they're kind of designed with one in hand. And then as you sort of integrate these different pieces, you also have more and more people understanding what these tools are. There's community behind it. It's easier to adopt these tools because people are able to understand and know how to use them, because they've probably used them in previous roles, or maybe had some experience. So it's easier to adopt these across the organization. And then you're not really stuck with any one of these specific tools. So if your company is making a pivot switch onto what environments you're going to be working for, you can use the right tool at the right time, instead of focusing in or waiting for some proprietary solution to say, oh, well, hopefully this hits our bottom line so we can use that later down the road. And then it also lowers your costs, because a lot of open source is focused around how do we improve the developer's life. It's not necessarily, how are we going to save money, or how are we going to get the most data out of these environments, and different things like that. So now we've learned, okay, we want to collect with open source. Well, what open source tools do we want to collect, and what type of telemetry data are we going to be collecting? So in my opinion, I think the three main sort of data telemetry types, or data collections, that we're going to be doing are centered around metrics. And when I say metrics, I really mean time series data. So a prime example would be something like CPU, or memory usage, or something to that extent, where you're talking about a specific date and time, and you have the actual numerical value associated with that. So time series data. Then when we talk about log data, or like logging or log management, we're talking about text strings from systems, different things like that. I'm sure everyone's aware. And then the last piece is tracing. So if no one really understands tracing is a concept of creating trace IDs, or sharing of data or anytime applications make requests or do units of work, they're associated with a trace, and those traces are made up with spans. And essentially what trace data allows you to do is kind of get a distribution of what your applications are actually doing, so on specific calls, so you can really pinpoint and find where the problems are. So if you collect, or if you bring together metrics, logs, and traces, it really allows you to do full observability, or full monitoring of your actual systems in and of themselves. And I'm going to walk through a specific example showing how these three pieces can come together. And the pieces that I'm using and coming together with are using Prometheus, using FluentD, and then using OpenTelemetry. And altogether, all three of these things together, we can ship them into any number of products. So there are dozens and dozens of products that you could use. Prime examples would be something like Elasticsearch, or you could be shipping them to like Elasticsearch and Metric Beat, or Elastic APM as an example. You could be using Grafana Labs as an example with something like, I don't know, they use Loki or Tempo. What we're going to be using, and what I'm going to be showing today, and sort of where I'm coming from, is Logs.io. So Logs.io, what we are is we're a fully managed SaaS offering for Elasticsearch and Kibana, soon to be OpenSearch. And if you want any information on that, you can check out our website. We have a lot of blogs about that. So we have Elasticsearch, OpenSearch for log management. We have Grafana and Prometheus as our infrastructure monitoring or time series data. And then we have distributed tracing done with OpenTelemetry and Jaeger. And together, all three of these, I'm going to show them what they look like in a specific platform, and how we actually get the data into our platform, and what we're going to do with that. So the next piece that I'm going to cover is a specific example and showing you what it looks like, how our data comes in, and sort of what we're going to do within our specific platform. So the demo that we have, or the environment that we're using, is the sock shop architecture. If anyone's played around with any microservice architecture you might have used or worked with the sock shop, I'll share a link with, I'll share a link on GitHub to actually show you the project that we're using. You can download it, use it, all that stuff. Basically, this project uses a combination of a bunch of different services. I'm deploying it on EKS with an Elastic Load Balancer, and I'm using Node.js, Java, Go. So a bunch of different services all kind of wrapped into this e-commerce application to show you. And I'll actually show you what it looks like in a minute. And basically what I'm doing with these services is I'm using exactly what I specified before, is I'm using FluentD, Prometheus, and OpenTelemetry to actually show this data in the platform, or to actually collect and ship this into logs.io. And you can see here, we have all the different services set up with these environments, and we can do that inside of our applications. So how we actually are, and this is the actual link itself. I'm sure we'll give you guys access to the actual application itself, or to the slide deck after. But basically, what we're doing in this specific case is we have, these are the three specific scenarios, or these are those three specific pages, and I can share those later. But what we have is, for Prometheus, we are using a remote write argument to ship Prometheus metrics into logs.io. So essentially, all you need to do to your existing Prometheus, if you're using that today, or if you're going to use Prometheus or want to know more about it, basically we're going to use auto discovery for our collecting our Kubernetes metrics and from our environments, because we have data coming from our control plane, we have data coming from our actual applications, and we have all of this information coming from our Kubernetes environments. But once you start going at scale, it becomes very difficult to actually ship all this to one place. So what we're going to do in this case is we're going to use Prometheus remote write. So you add in your URL for logs.io listener, or you use a barrier token. So a barrier token is essentially, we use a tokenized system for our different databases of information that we're going to be using. So in this case, for our metrics, we're going to have a metric shipping token. And then down below, we're going to use, so the next step down here, we actually have a exporter within OpenTelemetry. So if you use OpenTelemetry or have heard anything about it, OpenTelemetry Collector, the contribute version, we are actually inherent inside of it. So you actually have logs.io as an exporter. So all you have to do is add in your logs.io shipping token, and then you can also add in your region. So in this case, we're just using a US region. This is directly from our GitHub pages, as you can see. And then down at the bottom, you can see we have logs.io listener once again, and then we're creating a secret with a shipping token. So our shipping token in this case was going to be specifically for the logging aspect. And then the last part there, we're actually using a daemon set to ship the FluentD logs into our, or the logs from our Kubernetes environments using FluentD daemon set. So that's sort of how we're getting all the data into the platform. So I can quickly show you what the actual application looks like ourselves as we climb through this application. And I want to show you a little bit about, how would you set up shipping logs.io data into the platform very quickly. So I'm going to go into a very quick demo. So let me see here. So I'm going to share my screen. So sharing my screen here. So this, as an example, so this is my logs.io, or sorry, this is my demo application. This is the sock shop itself. As Cody mentioned earlier, how do we get some of these socks? Your guess is as good as mine, but this is what we have for our e-commerce application. So as you can see here, we have many different socks we can add to the cart. We can do all of these things inside the application. So this is a very specific example for this environment. And what we can do here, we can see here is where all the data is actually getting shipped. So when the data is actually coming into this specific environment, we can see here that it's breaking down into the actual microservices themselves. So very quickly, you can see we have data coming in from our front end, users, catalogs, as you saw in that diagram before. So we can actually get an understanding of where all this data is coming from and getting shipped into our platform. And like I said earlier, we're doing all of this through our Fluentd daemon set configuration inside of our environments. And then what we can see in the platform, we can also talk about or show you how we actually send the data into the platform. I'll just quickly go over how the data is actually shipped inside. So within our platform, everything has, within logs, metrics, and traces, we have detailed instructions of how to get different data into the platform. And you can actually see here with containers and pods, you can see we have Fluentd daemon sets within Kubernetes, and you can set that up with step-by-step instructions, and it actually includes all of this inside the platform. So we also have metrics. We can do the same thing with remote write with Prometheus. And then for tracing, we have the same thing with open telemetry instrumentation and setting up the collectors to actually ship the data into the platform. And you can even see here, we have Kubernetes as well in the platform. Awesome. So now that we talked a little bit about how we actually get data collected, at least specifically into the Logs.io platform, now we want to talk about, okay, well, how do we organize or how do we optimize the data that we are collecting? So we're shipping it from our Prometheus, we're shipping it from our Fluentd, and we're also shipping it from OpenTelemetry. But when we ship this data into our platform, what it does is it produces a ton of data. And as you scale as an organization, there are many considerations that you have to consider as you're scaling. So one major aspect when it comes to producing this data is what, from a compliance perspective, what data do I need to keep and why? And when I am keeping this data, how do I actually keep that data? Do I need to make it searchable live all the time? Do I need what resource considerations do I need to do when I get this data? I know a lot of times when it comes to logging data specifically, a lot of it can be very, very repetitive. There can be a lot of it going on inside of our environments. So you can get lots and lots of log messages, but when we're collecting all of this, do we keep all of it? Or when we get Prometheus auto discovery, because Prometheus and Kubernetes together are kind of inherent, like I was mentioning earlier about like the CNCF, it collects everything, every metric conceivable. And when you're deploying on these small nodes or you're not doing necessarily everything at scale, as a prime example, I had a customer that was shipping 3 terabytes of Prometheus metrics data per day. Now, obviously, that's a huge scale and that's a lot of data. But as you scale as an organization and you're worrying about collecting all of this data, it becomes harder and harder to understand what am I doing with that data and how do I optimize it? How do I send it to the right place? How do I make sure that it's not breaking my environments and things like that? And then the last piece is centered around tracing and sampling. Now, sampling is sort of it's a hot topic issue, and there's a lot of philosophies that go into tracing and how we do sampling. So, classic examples is based on like head or tail-based sampling. So, if anyone, no one really knows what header-based tail-based sampling is, basically, do you sample the data before looking at it, or do you analyze the data and then do sampling after? So, a prime example would be, do I just take 10% of every log or every trace that comes through? So do I just remove all the other traces and only just take 10% or 90% or whatever? Or do I analyze the logs and do something like I keep only 10% of my status 200 requests, and then I keep 100% of all 500 errors, as an example. So those are just different ways to do it, and it does have different resource constraints on your environment. Do you put more resource constraints on your collector and then ship it over, or do you worry about the system on the other end and have them do some sampling on their end? And there's different philosophies and how people believe that it should be done. But I think as a general rule, if you're starting to introduce tracing into your environment, I would do it slowly, service by service, and sort of understand, okay, well, what pieces am I going to get out of this? And then kind of start to roll back some of that tracing and do some more of that sampling. Another key aspect when it comes to producing a lot of data, as I mentioned earlier, not all data has the same value. So what I mean by that is okay, let's break it up based on environment as an example. We have some data may only be used. So dev data you may only want your developer data to be searchable for 2 days, whereas you need your production data based on compliances and different things like that. You may need it for 90 days or 30 days or 14 days, so that you can do complex log aggregation or complex log analytics or something like that. Well, because you have varying times and data storage, it can be difficult when you're dumping everything into one place. So if you're dumping all of your data that you're collecting, so you collect all of the stuff and then you dump it all into one place. Now, once it's all there, now your resources may be pushed to the max, because now you have all this data that may have different requirements depending on when it needs to be used and on all of these different pieces. And then there's another concept of, well, if we are getting repetitive data, well, what if we just left data out completely? What if we just didn't store it? Or what if we just removed it based on certain criteria? You say, hey, based on this specific criteria that we have met, what if we could just remove it altogether from being stored? And then that way we can focus more on what's important, or really highlight what do we care about and why? Why do we care about those things? And so when it comes to the data, it can be difficult to kind of get to that point where you're leaving data out, or you're trying to figure out like what values or what's important and why. So not only are we trying to understand, okay, data doesn't have the same value, but a lot of times when it comes to the actual data itself, especially for compliances and different pieces like that, we need to segregate who can look at what pieces of data, like who can actually see these different pieces. So going back to the example of developer data or IT work or something like that, a lot of times developers don't necessarily, they want to have that dev data, but they don't have access to the production data, or they shouldn't have access to that data. So for security and making sure that you're kind of putting bottlenecks on your certain data sets, having that restricted access can be extremely helpful for a lot of teams, because that data can be sensitive, and we want to make sure that we're not sharing that data all around. Other pieces that might happen is trying to restrict who's actually using what resources. So a lot of times developers, when they're using these open source tools, they start to enjoy, or they start to see, oh, wow, we're getting a lot of advantages out of understanding what's going on with our logs, or we are understanding what's happening with our applications, because we get more of a holistic view of everything that's happening. And as you're taking more pieces or bites out of this pie, your resources then start to get overloaded. And a lot of teams start abusing those resources because they start using everything that they got. Because you give, it's kind of like the whole, give drug addicts, start giving them more and more drugs, they're going to start using more and more. So it's really the idea of, we start giving this to more and more teams, and we want to sort of limit how many resources they can use, so we're not abusing our systems and things like that. And then also maybe you want to understand where the data is coming from and where it's actually being allocated, because Not necessarily all teams have the same budget, as an example, or maybe they don't necessarily need the insight that they're using it for, or maybe we want to restrict how much data is coming from each one of these environments and different things like that. So really, when it comes down to it, when it comes to data organization and sort of the optimization of these data sets, we really want to make sure that when we're producing all of this data, not everything is the same, and maybe we want to control who can see it, and we want to segregate where that's going. So I think we had another poll question from here. Yes. Cool. And the poll question is basically, do you agree or disagree with the statement that organization struggles to prioritize data or resources at scale? So I'll give a couple seconds here for. All right. Cool beans. So, all right. So for how so looks like here, we have about 85% of the people agree, or I guess don't disagree with my statement that that there is some struggles when you're prioritizing data releases at scale, because it becomes harder and harder because it's not something that you always think about when it comes to collecting data. Awesome. So for us here at Logs.io, what we want to do and how we sort of handle this specific scenario of optimizing and understanding where these data sets are coming from and where they're going is we center this around. So one, we do the data collection, so we can collect that data from anywhere. So in our case, we're taking it from that Prometheus, Fluentd, Open Telemetry. We're getting all of these events, the log metrics traces. And then what we're doing is we're actually sending it through a data optimization manager. So these are some specific features that we have within the tool itself. So we do have some machine learning and AI to help you identify things like patterns or maybe exceptions. We also have features like drop filters. And I'm going to walk through and kind of show you guys what that is and how that works. But basically what we can do is we can help you organize and strip out a lot of that noisy data that's coming into the platform so that you can actually prioritize and understand, okay, this is the data that we care about. And then from there, what we can also do is optimize and organize where this environment or where this data is going based on, we use a concept called accounts and sub-accounts. So we can actually restrict the access completely from our different data sets, so that you could have developers looking at data that they only care about as a developer. And within that sub-accounts and within that control that we have of the data sets, we can actually have flexible volumes. We can have data restrictions on those. So we can cap accounts and say, hey, no more data can come in from this account if you exceed this value. Or we can even create shareable buckets so that customers or clients can actually pull from that major bucket sets. So we can really break up the data based on who needs to access it. We can share that. We can provide analytics. We can create sort of a parent and child account. So you can actually have the parent look at all the accounts and provide analytics and understand what's going on across all the accounts. And then you can have those individual sub accounts where customers can actually look, and then you can have full RBAC on top of that. And I'm going to go through all of this and show you what it looks like in the platform. And then after we get through all of that, we can then provide the analytics, the alerts, and provide some more of that data correlation and things like that. So I'll show you more about that in the next section. So I'm going to go directly into the demo now. So I'm going to go back to the screen share. All right. So now that we've talked about, we've gotten the data into the platform. We've sort of organized, what we're going to be using. And now what I want to do is I want to talk a little bit about what features or what tools do we have at our disposal within Logs.io to help our customers to really understand and leverage the ability to actually organize and optimize the data that's in the platform. So what we have here, and I'll show you what I mean with machine learning and AI. So outside of just normal Kibana, you're not going to see these features of patterns and exceptions as an example. So we have this patterns feature. What this does is it actually breaks up logs into what we call buckets. And these buckets are for manageable. Instead of looking at each individual log line, we're taking these repetitive logs and grouping them into buckets. And these buckets allow our customers to be able to understand how much data is coming from each one of these systems. And we really understand the ratios of these different environments. And what we can do, and I'll show you what this looks like with drop filters, but what we can do is we can create criteria that we want to search for, and then we can filter those data sets out. So if we understand, hey, I want to remove carts merged from our logs as an example, or sent cookies, that could remove 2% of our logs. And if we're talking about gigabytes or terabytes of data a day, that could be saving us thousands of dollars by just removing these data sets from getting ingested into our platform and really lowering your log volume. On top of that, we also have the ability to actually pull out exceptions. So not only are we kind of simplifying what you're doing and how you're pulling the data in, but we also allow you to see exceptions. So we pull those exceptions automatically out of the logs. So you're not having to look at, as the logs are coming through, we're just prioritizing and pulling out the exceptions as they happen. So when we're actually getting the data into the platform, we have these tools or these analytic tools that can help us understand what's happening with their log messages, but maybe we want to do things like drop logs from being ingested completely from the platform. So we have things like drop filters. So really prime examples of how drop filters are used by our customers, or many times our customers use things like turning debug level logging onto their system. So what we can do with drop filters is it's a way to dynamically turn on filters to remove log sets from our environments. So as a really good example here, we also have load test logs coming into our environment. We're actually removing, so anytime our container that's coming through is equal to load test, we're removing that from the environment completely. So what that means is we're actually making sure that it's not getting ingested to the platform, because we don't want to get overloaded with data that's not important to us. We don't care. We don't want to use this. And what we have inside the platform is we actually have a way to dynamically, or I guess anything that gets sent into the platform, we also have, for compliance reasons, we also have a way to fork all the data into an S3 bucket. So if the data is coming in, what we're using here is drop filters to remove it from getting ingested and indexed into a Kubernetes or into our Elasticsearch database. And then what you can do is make sure that you're only focusing on logs that you actually care about. And then if you want to actually investigate and look at those logs, you can just turn these filters on and off whenever you're doing them. So some customers will do that for log level, as I was mentioning earlier. So if you want to maybe turn on debug level logging, and you want to be able to look at your logs whenever an issue is happening in your environment, you can do that. And then once you actually find the issue, you investigate it and figure it all out, you can then turn it off to then reduce your volumes. So it's a way for you to toggle on and off dynamically inside of your projects, rather than just saying, hey, we're just going to ship everything. Hopefully we're able to find what we're looking for the 5% of the time that we're doing it. And inside of your environment. So that's what we're able to do here within Logs.io, is we have these features to be able to do that and really kind of narrow our search and be able to do that. So not only are we able to apply drop filters, we can remove logs from being ingested into the platform, but we also have a way to organize our data based on, we can actually manage our accounts. So I was mentioning earlier a little bit about how we have a tokenized system. So each one of our accounts are broken up into accounts and sub-accounts, as I mentioned earlier. And these accounts and sub-accounts actually allow you to reserve certain volumes for those specific accounts. And what you can do with these certain sub-accounts is you can actually break up and have people only access the data that they want to see in their environments. So we can actually restrict, hey, I only want people to look at I only want certain subset of people to only look at sock shop dev accounts or sock shop main account. And you can actually restrict that access, and you can do that very quickly here within the platform. We can also restrict what data is being shared across those different objects. So you can actually have it searchable by the main account. So in here, what this is doing is it's just giving you a checkbox saying, hey, this is not searchable by the main account. So that means you won't provide any analytics over that, but it also will limit who can actually look and access that data. Or you can make it shareable or searchable by that main account, so that you can maybe have a team with some global views that want to look over everything. We also have a concept of flexible volume. So we can have some overage. So we can actually share unused data across all the different environments. So in the context here, you can see we have 20 gigabytes of daily retention here set up. And what this 20 gigabytes tells us is that only 15 gigs is being used across our 3 accounts that we have set up. And then what we have is a 5 gigabyte of flexible volume. So if any one of those accounts goes over there, like if SockShop goes over at 6 gigabytes of retention or reserve volume, it'll dip into that flexible volume so that it'll allow you to have some of that overage. So it allows you to just not have your accounts go over inside of your environment. And this is going to be the case for any one of your environments. So whether you're talking about your tracing tool or whether you're talking about your metrics accounts, we actually are able to show or able to break up all these environments based on these different accounts. And all of those are using unique shipping tokens to do that. So we actually, from the shipping aspect, are able to separate and segregate all of your data. So you're able to manage where the data is coming from, and you're able to actually change your tokens, and you can actually set it up in those different environments. So you can actually go in and manage these tokens. So if you say, hey, we have a bunch of services I want to turn off, you can turn that off and make it so that those tokens are no longer used. And then when it comes to actually managing the users, we within the manage users tabs, we have, as it stands today, we have 3 different types of users. We have read-only, we have user, and then we have admin. Basically, read-only is exactly what the name is. It's read-only. So as a user, you can only look at the different aspects within the platform. You can look at visualizations and different things like that. As a user, you can create visualizations and make changes. And then as an admin, you then can remove visualizations, or you can add users and do different things like that. We can also set this up with SSOs and different things like that. So if you really want to manage who has access to these accounts and who's running these different pieces and aspects, you can do that as well. But that's really what it comes down to it from a data management perspective and a user perspective within the product. And then I think the only last piece is when it comes to archiving. So when I mentioned earlier about drop filters, one of the biggest concerns when it comes to dropping data from getting ingested into the platform, I mentioned that we can fork everything into an S3 bucket. So that can be for long-term storage for your logs. And then what we have is a feature called archive and restore. And what this will do is it'll actually pull logs back into the platform and allow you to analyze them and look at them inside of its own separate index inside the environment. All right. So now that we now that we talked about optimizing that data, and we talked about how we're actually using this, I think what we wanted to do is I wanted to talk about how do we actually correlate that data together? How do we use all of this data in one single place? How do we visualize everything together? Because unfortunately, when it comes to using the best tools to detecting and finding and diagnosing issues inside of your environments is obviously you want to use the best tool and what it's designed for and how it's used. But the downside is then you start to kind of limit your team's ability to be able to do different things within those environments. A lot of that can be centered around only really understanding it from one point of view, because Unfortunately, if you're looking at everything from an infrastructure side, as an example, like let's say you see spikes in CPU usage and you say, well, these spikes have nothing to do with what our environment is. It's we didn't make any changes to the actual infrastructure, so it's not an infrastructure problem, and we have some overage, so it's not our problem. And then the distributed tracing team may look at it and say, well, we see the calls are coming through and we're not seeing any errors, so that's not our problem. And then you send it over to the application team and they may look at it and say, well, we see a response, so it's not our problem. So then how do we understand and how do we bounce around and figure out, well, whose problem is it? Because everyone's saying, well, everyone likes to point fingers. Well, I shouldn't say that, but a lot of times finger pointing really comes down to it because no one really wants to be responsible for issues in your applications. So that's where a lot of that one-sided story can really come in, or really limiting your team's ability to kind of look at issues. Okay, another example would be, well, it is one team's problem, but how we got to that and how we got alerted on it or how we figured out what was going on is we had to contact 3 other teams, or we had to get somebody on their weekend, and they had to, spend their time trying to figure out, okay, well, someone from the DevOps team has to come in and tell us, okay, well, this is the resource that we need to focus on. This is what's going on. So we need to actually we need that shared information, and we need to really understand and get access to those different pieces. And then when we actually get access, sometimes it really limits the context as to what we're actually doing with that data. So we say, okay, well, this is the time frame we're looking here, and then you have to move over to this other piece, and you have to put in these filters, and you have to figure out, okay, this is what we care about, and this is what we're using, and different things like that. So that data correlation then gives us extra steps and makes us spend more and more time doing these types of things. So when we're using these tools, obviously we have each one of these tools are speaking their own language, and they're kind of doing their own thing because they're doing what works best for them. So a lot of times, like a really prime example would be something like inside Prometheus, they use label values as to label different metrics and different that time series data that I was talking about. And as where with Kibana, we use fields to be able to do this. Well, sometimes these values can overlap. And when these values actually overlap, when you're speaking these different languages, well, what do we do when that happens? Is it just, oh, well, that's just a really good coincidence, and maybe when we're actually investigating or we're looking into these problems, this is what we're going to care about, or this is what we're going to be doing? Well, that's one way to do it. Or within Logs.io, we have a more unique way to actually do that in the platform. So how we achieve this problem, or how we solve for this, is if you jump into our metrics product. So going, actually, maybe I want to switch over to the right slide. Why is this? Okay. And then, so if we go into the actual metrics product, let's see here. That's how you share your screen. We are able to actually bring all of this data together. So inside of the Grafana visualization, we actually can bring in or overlay your tracing data. So we have tracing data coming in from Jaeger, as we can see here. So this is our latency by a service. So all those services that I showed you earlier, the carts, the catalog, front end, payments, all of that stuff. We have the spans per service, so we can see all of these coming through. We know the errors that are coming through. We can actually overlay logging data on top of this as well, so we can see things like deploying new versions inside of our environment. We can see CPU loads, memory usage per pods. We can see when pods are going down or they're created. We can also look at the latency per operation. But obviously, this is a lot of data coming in, all from different resources, all different backends, all different ways to actually see this data. So what we did here at Logs.io is we are trying to introduce tools to help you to actually narrow that scope. So the way that we do this is through unified variables. So I will show you guys what unified variables looks like. So unified variables allows us to take different, so as I was mentioning earlier, we have different tools or different ways that we're collecting this data, and they overlap sometimes. And when they overlap, how can we intelligently tell us to use that data? So the example that we have here is a really prime example is the word service as an example. So service allows us to take, as an example, we can take from our tracing backend, we have the data source that we're picking. We are looking at process.service name. And process.service name is exactly the same as from our metrics account, Prometheus label value container, or our Kubernetes container name comes in from our sock shop, from the logging account. So now what we can do is we can overlap these different fields to allow you to create searches across our environments as we're using them. So I will show you what that looks like. So if we go back into that overview of our environment, we see here we have our tracing data. We even have the log messages down here at the bottom that's coming in from each one of these services. And we're looking over the last 12 hours. Well, what we're able to do is actually create a filter based on that filter name service. And we can say whenever that service equals, and if we want to look specifically at the payment service as an example, we can actually create a filter. We can filter all of those different data sets and just look at the payment service based on that service name. So now we can intelligibly look at all the different things like latency per service. We can look at spans per service. We can actually see when the memory of the certain pods that we care about are breaking down. So we can actually correlate all of these different data sets together because we're able to have these different data sources. Because if we were to just create some type of variable at the top of this list, we'd have to have a variable for each one of these graphs. And that would be a huge pain if we're going through each one of these visualizations and saying, okay, well, what data source do I care about here? And where am I setting this up here? Instead, we're creating some global variable for all these. And what we're able to do is actually look at, able to look at the logs that are coming in per this service. We're actually able to even see the log messages as they come through. And we can actually investigate on specific issues. So we can see, since I know this environment, I know that there's a bunch of issues that come up. And what we can do is we can focus in on those specific issues. So we can see the latency spike of these specific operations, or we can see the CPU pod drop down in memory or CPU drop off and see reloads that are happening. And then now that we're able to correlate all these different data sets and look at all this different information, what we're able to do is now we can create what we call data links so that we can look and jump around from one data source. So we can say, okay, we're looking at the logs of specifically our payment service. Well, what if I want to just focus on the errors of the logs that are coming through? And I want to investigate it specifically in a Kibana view? Well, what we're able to do is we can create these data links to help us investigate and look at these specific issues inside of our environment, so we can create the correlation that we want to see. So we're actually taking the time frame that we had before. So we're looking at what was happening in our metrics product, and we immediately jumped into our infrastructure, or into our logging Kibana view, and we can really look at and see, okay, what is the error that we're getting inside of our environment? Why do we get this error? Maybe we want to create an alert for this error or something like that. So we can do all of this inside of our environment. And we did this all through data correlation and really understanding, where are these different data sets coming from, and we can really kind of overlay and see what's happening inside of our environment. We could also do the same thing by jumping into our tracing product and maybe look at specific traces or different things like that inside of our environment. But this is really all I had today to talk about. I know we have about 10-ish minutes or so. I wanted to kind of leave the floor open for questions. If anyone have any questions or anything that you'd like me to cover specifically, I know I wanted to leave some time for that. Anything about logs.io or anything about specifically Kubernetes services or anything that you'd like me to cover, I'm more than willing to. And then I think that's all I had.
So Spencer, we do have one final poll if you want to launch that one.
Yes, that would be awesome. I think, yes, I forgot about that one.
No worries. Bring it up right now. So what are your main challenges in gaining observability into your cloud environment? Data collection, data organization and optimization, data correlation, all of the above, or other? And we are still receiving responses in real time, Spencer.
Okay, cool. So it looks like so far about half or so, or at least a little over half, are saying all the above. I think that's probably the case for most people, and that's sort of probably why you're looking at something like this. I will, yeah. So I mean, I think the idea of centered around it doesn't surprise me that all of the above is probably the biggest one here. I think data organization optimization, I thought that would have been higher, to be honest. Oh, I guess there it is. But I think in my opinion, data organization optimization is really imperative and important to a lot of organizations, because as I mentioned earlier, as you start to scale as an organization, it becomes harder and harder to like with those data lakes, as I mentioned, to make sure that your data isn't breaking your environments, or that you're staying within compliances, because it becomes increasingly difficult, especially in a cloud-based architecture, to make sure that you're staying with those keeping up to date with the compliances, especially like I see some of the people here, saying they're from some EU and stuff like that. So cool. Awesome. I think that's
yep. We just received a question, and this person asks, how is the price per gigabyte of stored data stacks against Grafana Cloud?
That is a tough question to answer, because I will say probably from a cost perspective, we're probably more expensive than a Grafana, but that's just because of the way that our logging is a little bit more on the more expensive side, but that's just because of the way that we index the data. But it does allow you to do a little bit more complex investigation on the logs themselves. We do have some different tiering options and different things like that. So price per gig is very difficult to say. I will say that we probably are a little slightly more expensive than Grafana Cloud. But we also have a little bit more added features with regards to being fully managed, as opposed to a hosted model. So that means that we do things like data parsing on your logs, as an example. So that allows you to do a little bit more complex investigations rather than just doing everything through metrics, stuff like that. I can send over more information about how our pricing works as well. And then, so I think the next question was, do you guys have something like alarms, incident management features? So we do have the ability to create alarms or alerts. We do also have incident management features within the platform. So you can, so our alerts or our alarms can be sent to any number of endpoints. So we have a lot of third-party integrations with things like Slack or Teams or PagerDuty, as an example. So you could use those as an incident management. I know a lot of organizations are. We also have ways to send alerts to specific users and different things like that. So we do have all of that in the platform. So you can create alerts based on logging data. You can create alerts based on metrics. We're actually just starting to implement the Prometheus Alert Manager as we speak. So if it's something that you're interested in and you want to see that, we can try it as a beta feature as well.
So Spencer, I'm going to give our audience just another minute or so to send in any questions while I give away a couple gift cards.
Sounds good.
So these are for 4 $25 Amazon gift cards. Our first winner is Jim D. Our second winner is Raja M. Our third winner is Jayaramulu G. And our fourth and final winner is Vikas S. So congratulations. Keep an eye on your inbox to claim your gift card. And if you don't receive an email, check your spam folder. I'll also remind our audience that the session was recorded. So following this webinar, you'll receive an email with a link to access the recording on demand. You can also find it living on the DevOps website at devops.com/webinars. So Spencer, that looks like we've exhausted all the questions that we're going to receive today. So anything before we close out?
Nothing more from my end. If you have any questions, I believe, I'm not sure if my email has been attached or anything like that, but I'm sure if you have any other questions or anything like that, you can always ask the Logs.io team and mention that you came here from the webinar, and we can point you in any direction you need. But it was really nice talking with everyone here today. Hopefully, I was able to help anyone just understand our product a little bit more, understand how do we solve these unique problems.
Well, Spencer, thank you so much for being here with us and for putting together your demos and your presentation. I know a lot of thought goes into these presentations, so I really appreciate the amount of work that you've put into this.
Yeah.
So I would like to officially thank Logs.io for sponsoring today's webinar. And my final thanks before we sign off today goes to you, our audience. Thank you for attending today's webinar. Please take just one extra moment to fill out our post-webinar survey, and we hope to see you at an upcoming Techstrong Learning event. Thank you so much, and everyone have a great rest of your day.